Welcome, everyone, to the Ad Dot podcast. Today I have Lev Gordinsky, or Leo. Lev and I met probably 12 years ago or more now in Denver at the Denver DDD meetup. He was involved in DDD and he reviewed my red book, and I put an acknowledgement mention of him there in the book. So welcome to the podcast.
Thank you. Good to be here. It's been a long time.
Yeah, we've maybe crossed paths just a little bit. I think we spoke a few years ago during the pandemic. But yeah, good to have you on the podcast. So you were working, I guess you were in Boulder or Denver back then, and in Colorado. And then you got recruited by Jet. Mm-hmm. Can you tell us a little bit about that?
Yeah, so I got recruited by Jet. At that point, it wasn't even called Jet at that point. It didn't come up with a name yet. It was just a no-name startup out of New Jersey. But it sounded like they had a really great mission. One of the reasons they reached out to me was actually based on my activity with the DDD community, all the posting on Stack Overflow, your book, all those things. So it was a nice way for DDD to lead to something like that.
Yeah, and absolutely. And I think so I'm trying to think of all the timing of it, but shortly after my book was published, I think it was around June or July of 2013, I was teaching my workshop. It was sort of like the last DDD tour IDDD tour location in Denver, Boulder. We actually had the workshop in Louisville or something like that in Colorado. And I had you, because of your interest in F#, I think, and functional programming, I had you do a presentation and maybe some little bit of training or something like that, introduction for people to functional programming. And so that was pretty interesting.
Mm-hmm, mm-hmm. Yeah, I remember that now. I actually had forgotten about that, but I remember it, yeah.
Yeah. And then I guess at Jet, you were able to use F#, right? I mean, wasn't that sort of primarily your
Yeah. And it was actually interesting because when we started at Jet, I was one of the first hires. It was really three of us that were like the first hires. We all started at about the same time. And I was the only one that knew F# at that point. And so we started with the least amount of friction. We started with C#, but then I was writing my code in F#, and then we kind of agreed that we would just see what it looks like. But then after a couple of months, it wasn't up to me. It was the CTO who made the call that said, "Hey, we'll just switch everything to F#." And I think some of that was due to perhaps my evangelism. But I think what was really happening is that he saw me and he's like, this guy, he'll do anything to code in F#. Like, maybe there's others like him. So let's see if we can find some more. But on a more serious note, I think that the passion in the community, the F# community, similar to the DDD community, I think that's very valuable.
Yeah. And so then, yeah, I remember seeing tweets from you or somehow. Well, I think when you finally did have the name Jet and started to attract more attention, I think your engineering team got a lot of notice from that. And yeah, very, very cool. And what, you ended up being vice president of engineering or something there?
Yeah. And that was, I guess, early on, we didn't really have any titles, but we grew very quickly. And so we had to build in the corporate infrastructure for all of that. So, yeah.
And so for those who don't know, Jet was eventually acquired by Walmart. Is that correct?
Right.
Yeah.
Right.
And actually, some folks at Walmart, I think one of the guys, I can't think of his name right at the moment here. Some of these memories are just coming back, but he had me speak to a large group at Walmart some time ago, and that was my connection with him was through you. I think he even attended one of my workshops, and
I think that was Robin.
I think you're right. Yeah. Yeah. So anyway, nice to get reacquainted with all these old memories. But let's talk a bit about your experience with software development in general. And if you were to look back, say, 20 years in the software development industry, how have things changed in the past 20 years? And then maybe even an acceleration of change in the past 5 years. What do you think?
Yeah, so if I look back at the early 2000s, we had a very different landscape. That was when I think the cloud was just starting to emerge, but we had nothing like we had today. I remember I started getting into the cloud in like 2007, 2008, and it was a very early stage product at that point. But before the cloud, the software development was quite a bit different. I was still working myself. I was still working on internet-based services. That's all I ever really did is worked on various. I actually back in early 2000s, I was working on what now Gmail and the Documents service provide. I was working on like a productivity application, and I remember I was actually writing it in Perl. And then a few years later is when I got into C# and also no cloud, but we had an internet-based service that we were running on our own. So we had our own servers. We installed the SQL Server installation, and we ran IIS, and we had the one instance of that running, and that kind of lasted us several years. And so if we kind of skip all the way back to today, or even if we say, even if I look back when we started Jet, right? At that point, we were cloud native. We started in the cloud. And but with that said, the cloud, specifically Azure, was not as mature as it is today. And I think even AWS at that point, I remember using that as well. Compared to where they are today, it's a very different landscape. Like they've really figured out a lot of these things pertaining to developer productivity, certainly their own services, and they tend to be pretty reliable now. And so I would say over the last 20 years, some of the things that have happened are the migration to cloud and internet-based services and sort of the maturity of these approaches, the maturity of the infrastructure. There's been a huge leap in that. The other factor was that on the programming model side of things, it seems like one of the big shifts has been the embrace of parallel and concurrent programming, embrace of more and more features of functional programming languages in the mainstream languages that we use, because functional programming languages have been around for a long time. Haskell has been around longer than Java, but we've seen a lot more of these features from functional languages be incorporated into the mainstream ones. That's sort of another factor. The other role that emerged, I would say, in the context of software development is something I was posting about earlier today, which is this operational role. Because what's a service? What's like a microservice? Well, I'd say a service is a program written by a programmer plus an SLA, right? Because now you have to think about reliability, and you have your service level agreement. And so at least for my own experience as an individual software developer, that's been another shift, is really thinking about services rather than just individual pieces of code. So these are some of the things that come to mind. I guess the other thing that we had a shift and kind of leads into another thing I wanted to talk about, which was what happened with databases, right? And on the one hand, nothing really changed because we had relational databases 20 years ago. We still have them today. They kind of made a comeback. We had a period of like NoSQL madness for a while where we thought we didn't need SQL. But I think the fact that the relational model is actually a very solid data modeling paradigm. It turns out that we can't just get rid of it, and it's going to come in new shapes and forms. And I wonder if we think about what might happen next. I think that would be really nice to accompany this relational database model with an operational event-based model and combine the two to really see if we can use the power of both. I guess the other thing that comes to mind in this context is I remember writing services where a majority of the logic was in a SQL stored procedure. And so there's been a migration away from that. And I remember my reasons for migrating away from that were the fact that it was very difficult to unit test SQL Server stored procedures. It was difficult to make them modular. And even though in many ways that approach is a lot more efficient in terms of the network chatter between the database and the server, and at the end of the day, being able to consistently test your system and reuse code was a lot more important than efficiency. So these are some of the things that come to mind, but I'm sure there's other stuff that has happened.
Yeah, speaking of stored procedures, and it seems like there's a lot of Microsoft SQL Server stored procedure solutions out there, and they just don't scale. I mean, is that sort of what you found? I've engaged with a specific company that had I don't know. So I think they were getting something like 12 transactions per second was max, and that's ridiculous. I mean, we were seeing more throughput than that a long time ago on all kinds of databases.
Yeah, I think the scalability, and to me, it's mostly the flexibility of it, right? You can make a stored procedure run pretty fast, but it locks you into using just SQL Server, that one instance. You can't easily scale just that one instance. SQL Server is known for being difficult to scale. But with that said, it's not going to go away anytime soon. It's still a powerful model, right? SQL is actually kind of cool because you have the SQL query language to query the data, but they also have the data manipulation language where you can insert and delete and all that sort of stuff. And it seems like that's really nice. I mean, if we could just combine some of the things of the programming languages that we use, the general purpose programming languages, and combine that with being able to run code really close to the data, that could be really nice.
Yeah, I think one thing that's kind of strange to me is when we deal with NoSQL databases, it also seems like the query language or the query functional interface or something like that just becomes very sort of strange, unwieldy. Have you experienced that too? It's just like, wait, if you are used to SQL at all, it seems like they could just make it not SQL, but just a little bit more intuitive to people who've spent, 20, 30 years writing SQL.
Yeah, well, I think that's starting to change. I think they're doing that a lot more now. I think they started with, my guess would be that when they built some of those very popular NoSQL database early on, like Riak and Cassandra, and there was a few others. A lot of them were based on the Amazon Dynamo paper. But all those early ones, they were designed for a specific task, and this query language came in as a secondary thing. And it was designed where they did the simple things first. They didn't do full-blown SQL. They said, well, we'll do that later. And then when they come to it, they'll realize the complexity is the same complexity that SQL runs into. And you can't just, make something better that quite easily. But now they're kind of saying, okay, yeah, SQL has value. Let's bring it back. Like, for example, Cosmos, we use Cosmos, and it is a non-relational database. It's more like a document-oriented database, you might call it. But it has a SQL-like query language, but there's no joins. You can't join between tables or containers, as they call them. But on the other hand, you can have collections as fields in the object, right? So, for example, from the perspective of domain-driven design, you really store the whole entity in the document, and you can kind of query within it, but you can't join using Cosmos itself. You can't join containers.
Yeah, I think Martin Fowler called that the aggregate database or something like that, aggregate store. So referred to it as that. Because, yeah, you just sort of carve out this one chunk of, data structure, I guess, that belongs to a single DDD aggregate. And it just, kind of gets persisted very simply into the database.
Yeah, and by the way, Cosmos is a wonderful piece of technology. I think the joins. I actually have conversations. It makes me think of another post slash rant to write on LinkedIn, where I have other junior engineers coming to me saying like, "Well, we should be using SQL Server." To be fair, I think a lot of their arguments are valid, right? And one of the reasons, of course, they say is that so they could do joins, right? But this was, I would say, one of the primary reasons in the past I had trouble scaling SQL Server is that it's the fact that over time you end up in a data structure with all the relationships that involves a lot of joins, right? They're powerful and you start to use them for all these different scenarios, but having access to all these joins, it will inevitably lead to inefficiency in the system. So that's one of the guiding principles with Cosmos is they deliberately avoid joins. They kind of pass that on to the application developer to handle that. But I do see them at some point because you still need joins. Like you need to do it in the application, right? So it's like they need to solve it at some point. I think that maybe the technology isn't quite there yet, because one of the things that happens, one of the things that we kind of moved away, I would say, from SQL, one of the reasons that NoSQL emerged is that SQL is inherently synchronous, meaning you update a table, it updates all the indices, it does everything all at once. And it can't really message from SQL to other databases, right? You can access the transaction log, and they've done that with like Postgres type of databases, but it's not really designed to be used as like a write-ahead log directly. You can't really access the transaction log; it's not convenient. And so, whereas the NoSQL databases kind of made that one of their core functions. But yeah.
I think actually Debezium supports, I don't know if you've heard of Debezium. It's more sort of on the Java side of the world, but I think it would work for anyone. But it does support SQL Server, and it supports Postgres. The other interesting thing about relational is like there's a company called Yugabyte that maybe you've heard of it, that they have basically a Postgres emulator, essentially, right? They can emulate Cassandra. They can emulate, I don't remember, several different kinds of databases, and it's really built on top of RocksDB. I think the whole thing is. But anyway, they actually have global scale for ACID transactions, and it's actually not bad performance. So that's another kind of interesting development in database.
Yeah, there's quite a few interesting ones. I mean, Microsoft built their own Cosmos. Google has their own Spanner. And there's interesting third-party ones like CockroachDB. Also, it's like they're kind of addressing these things. It's SQL Server, but they can do asynchronous messaging and updates like materialized views and things like that. Because you keep running into the same issues with databases all the time, and it'd be nice to just solve them once and for all. You're always going to be needing to join in some shape or form. You're always going to need to have materialized views, and you're always going to need to publish an event whenever you perform an operation. Like, why can't they just make one database that does it all?
Yeah, I mean, what if we had a database that actually natively supported CQRS?
Exactly,
something like that. Just like it thinks the way that our applications need to work, I guess, or the services that we develop. Yeah,
I think the reality is actually that's very difficult to build that kind of industrial grade system, right? Because I think that Microsoft could have done it already, right? But I guess it's pretty difficult. Cosmos already is such a sophisticated piece of technology with all the replication. It's replicated within a data center. But it's also replicated across data centers, and you have various consistency guarantees for doing that. They had to create a new type of data structure for on-disk storage called like Omega trees or something like that. So it's a pretty impressive piece of engineering. I mean, they kind of redid the whole stack. The interesting thing though is that they run Cosmos itself on a piece of infrastructure on Azure called Azure Service Fabric, which is available for use directly. And I guess a lot of the Azure services are actually running on top of Service Fabric. Now, Service Fabric is quite interesting in that it's not quite the database that we just discussed wanting, but you can get some new types of architectures with it, right? Like we've all gotten used to, I guess the other thing that's shifting or potentially shifting is we've all gotten used to the 3-tier architecture: client, server, database. But Service Fabric shifts that picture a little bit because they have it where you kind of have your server and everything is in memory, right? But because it's a cluster of servers, you're guaranteed that one server will always be up, and it still commits it to disk, but sort of like asynchronously, right? It does the I/O asynchronously, but it guarantees that it's consistent for that short duration in memory when it's just being written, right? And then you access this data as if it were just a regular dictionary or a collection, right? You just look up a dictionary. It's just this dictionary ends up being committed on disk. And now this is the idea of where you start thinking about a system more like a video game, right? Where you have your entities, they're just objects that are in a dictionary, and you create new instances, you persist, and it persists exactly what you have in memory. And so with this idea, right, it's kind of moving beyond this N-tier model, right? Because in this model, it's almost like the in-memory operations is the core, because we tend to structure the whole application around committing to the database, right? The transactional boundary. It's all around avoiding transactions, or trying to avoid transactions, trying to avoid writing in multiple places. And that's kind of like the center of the architecture. Whereas if we kind of flip that around and the primary storage is in memory and it's kind of committed in the background, then you can really focus on the core logic. I guess this system also runs Halo for Microsoft.
Yeah, it's Microsoft Orleans is underneath that, and I think Service Fabric kind of took a snapshot of that, and or the team brought it in and based Service Fabric off of that. And actually, we have in our open source Zoom platform, reactive platform, our actor model, and Orleans is based on actor model. Service Fabric is based on actor model. We have a very similar, kind of operation, because actually the actors themselves make a very good, excellent aggregate boundary. So, like you send a message to even a type safe message, as like a method looks like a method invocation. You send that to the actor, and once the actor performs its requested operation, it can just simply apply an event to itself, but in the background that actually gets persisted asynchronously. Mm-hmm. And so any state, any sort of state query or state sharing, you don't share state, but sharing in terms of a snapshot of it is guaranteed to be up to date at all times. So it's it is a very cool model that I like it a lot. Yep.
So that works. That works pretty nice, and that's some of the things that we're doing at Alvis as well, exploring.
Yeah, why don't you tell us about maybe, I think we wanted to just discuss a little bit sort of what's next for domain-driven design. We've both, we met each other probably 12, 14 years ago around the, domain-driven design. So we've been around it for a long time. How do you see it changing or having a different influence than it's had before?
Yeah, so for me, I was always very interested in domain-driven design because the problem that it's trying to solve, to me, always seemed very important, and I've always been surprised by how little attention the academic community pays to these problems, and it's really under the radar, right? It's not really part of like an engineering discipline. There's this community that's trying to address the situation of like, how do we write maintainable, good quality code that's easy to evolve, avoids bugs. That's kind of the perspective I was coming at. I thought, what's the best way to represent knowledge, right? So it was a broader thing that I was thinking about. What's the best way to represent knowledge? Because we're building these systems to solve a certain use case. We need to create a model of the system that we're working on. What's the best way to do that? And this is a very much an open problem, right? And I think that when you're programming in a programming language, you are led into certain things more or less naturally. Like, for example, it seems natural to define a class with fields that correspond to the data that you want to store about what you're modeling, right? I mean, there's other ways to do this sort of thing, but that tends to be where you go, right? But then in simple cases, that works, right? If you have a CRUD type of application, you have a data structure, you can read it, update it, delete it, and you don't really need to worry about it. But I was working applications that were much more complicated. The CRUD model just breaks down. The CRUD model is a good way to think of your database, not about your application. And so I was looking for help in this regard. I was looking to see how have people addressed this problem. And one of the things I learned about was domain-driven design, which is kind of tackling this exact problem. And so that's how I got into the community and started interacting with everyone.
Yeah. So where do you think we're headed in the future? You mentioned programming language. Do you think that new programming languages and programming language designers might think in terms of, I don't know, building some primitives or something that match up to domain-driven design?
Yeah, absolutely. I mean, one of the things where I think, and this is something I'm kind of exploring in a more academic sense, is I think that where it should go is that we should actually look at SQL and the relational model and say, okay, I think that's valuable for domain-driven design, right? Because the relational model captures very important relationships. And these are things that you do need to talk about in the domain language. But the problem with the relational model is that it's only half the picture, right? You still need this operational model, and that seems to be missing. So what would an operational model look like? Well, you need a way that you need to do something that says, okay, given this input, this table will transform in this way. This row will transform in this way. And I think that there's value in making the components that make up the domain model first class. And here's what I mean by that. Like I said earlier, when you're writing in C#, let's say it's natural to represent an entity. You say class load, like we have in Alvis, a load or an order, and then you have order ID, line items, and created date, right? So that's how you represent this entity. Then when you start having a richer domain model and you use domain-driven design, you start adding events and behaviors that change the state of this entity. So if you're using C#, one of the best ways is that you just have methods in the class that, given some input, transform the entity and maybe return an event that can then be actually used for event sourcing purposes, or maybe it's just to return some sort of a response. And so all that's great, but one of the things that's actually very difficult to do with code is a refactoring, right? Refactoring in SQL Server is expressed in terms of SQL Server, or rather SQL, right? So you could say create new table, transform the old table into the new one. And so the refactoring operation itself is actually some SQL code, right? Whereas in C#, that's not at all the case. The refactoring is just you change the file and you commit it, right? And so that creates a lot of problems. The fact that these entities and their schema and the fields within an entity that aren't first-class concepts also poses a challenge, right? Because one of the things that's pretty difficult to do in a class is to iterate through all the properties, right? Well, you use a reflection, for example. But then with using reflection, you kind of lose a lot of the semantic content of what that property might be. In many ways, I would say domain-driven design actually leads you away from reflection. You have to explicitly think about every field. But I think if we had a programming model wherein we would define an entity almost like not as a class, but as an object, right? We say new load entity, add field, add field, add field. And then the fields, the data fields for the entity become first-class concepts, right? And then you could define operations as first-class concepts, right? One interesting way to think about event sourcing is that event sourcing takes an object like the event, right? It's just some data. takes this object and turns it into an operation, right? Because you can take this object, you can have the apply method that takes the input state and produces the output state, right? So this is kind of like we have some concrete data, but it actually turns it into an operation. And so I think that we can implement domain-driven design models by defining the fields, defining the entity as just like an object, adding the fields to it, and then defining the operations that say this operation is actually defined such that it takes these fields as input, checks this conditional, and produces this as output. And so then the operation itself could itself be code, right? It's just a sequence of steps. There's a fork, there's a join, and then refactoring would be more like transforming an in-memory data structure. And so if you could then take this object and you'd say, okay, I have an object that represents the load entity, and then you could create an instance, and then you take some data that produces an instance, and so I think one of the directions that's interesting to explore is this idea of making operations in domain-driven design first-class concepts, and taking the relational model and combining. And there's a lot of interesting work going on with this. I don't know if you've seen some of the work pertaining to modeling relational databases using category theory. And it's a very, very natural model. And the basic idea is that a database schema, where you have the tables and the relationships between them, that's just a category, right? And then the database instance is a functor. It takes a category and returns a set of instances, right? So it's a very, very natural fit for category theory. In fact, I think it's a great way to learn category theory. People that have done relational modeling, they're basically doing category theory. They just don't know it. But then what category theory can do is it takes it further, and it can actually represent operations and define them in a very explicit first-class way. And I think there'd be some value in that. And it's just a curiosity to explore.
Question I have about that is, would the operations be part of the object? Would you add those to the object, or would they be separate and you send the object to the operation, or like functional programming? What do you think?
Well, it would actually be flexible in a sense that the operation would just define the logic. And as far as, and I'm not sure if that's what you were getting at, but as far as the modality, right? Is it like, does it run synchronously, or eventually do we wait for a response or not? That could all be a pluggable parameter, right? You could say, in this case, I want the operation to complete synchronously, but in another case, it wouldn't complete synchronously. But I'm not sure if I'm understanding that correctly.
Oh, well, what I meant is, like, do you perform the operation by saying object dot, in essence, the operation, and then the operation has access to the data within the object, just like we have today in object-oriented, or do you see it more like the operation is a separate function that you pass the object to, or the type, sort of like Haskell or any,
Oh, well, yeah. I mean, I guess in that sense, that could even depend on the programming language that you used, right? Because I think this model you could implement in Haskell or in C#. So if it were C#, then it would be where you have an object that represents the entity. You create an instance of the entity, which is just another object, and then you kind of invoke an operation on them. And what I find actually to be most convenient is that you can kind of write the objects and make them seem almost like regular objects, where they have fields, but those fields, the properties that refer to the fields, they're accessing the underlying object that takes care of the fact that, okay, well, if you're changing a field, maybe it has dependencies on other fields. So you can't just set it, right? So you can encode relationships between fields and how they transform under events into the object, and then you don't have to think about it every time. Because now when you write these methods and you're accessing fields, you kind of have to think about it, right? Like if you have a really clean domain model, then it's nice. At least it's all kind of in one place. But thinking about all the different state transitions and all the things that are allowed, what's not allowed, and kind of housekeeping tasks, like the fact that you might want to the event should have all the data that was changed as part of the operation. Well, usually you have to kind of explicitly code that in, but it seems like that's something that could just be taken care of automatically.
Interesting. I guess from the standpoint of the question I asked, it could be that the language itself is flexible enough to handle either one, right? If everything is really an object of some kind, like even the operation is an object, then the object could be attached to another object which holds the state, or the object could be just a function that you have to pass the state to, to be able to perform, some kind of a functional.
Yeah, I think outside of the syntax, one of the mental models I always keep in mind is the fact that functional, non-functional programming, at the end of the day, you have state in the system, you have memory, and you have compute, right? And you have a computer reading memory, producing new states. And you have that with functional programming or non-functional programming. And so I always visualize, when I think about an operation, I do think in a more functional way. I think about like an input type and an output type. But you can also take a method and just assume that, yes, there's an input state and it changes when the operation completes. There's still some sort of a transition. Time passes, right? There's an arrow of time. And so I kind of really think about those things as being very similar. It's just the dressing is a little bit different. One of the things from programming languages that I think would be nice is like there's this construct in functional programming called a lens. And a lens is kind of a first class field, except a field is usually we have an object like an order, and then a field is an order number. Well, a lens is like a more functional way to think about an order number, where it's an operation that takes an order and produces a number, right? But then when you think about it that way, you can compose operations. And then the other thing that a lens can do is that you could say, okay, you could update the order number. And so given an order number and an order, you can produce a new order, right? So that's the two directions of the lens, is you can read the order number and it can update the order. And so I think if a language had a first class concept of these lenses, but it really need to be enriched beyond what's currently available. But things like that would help. Like, for example, one of the things that's always difficult to do in C# is to define a class and then iterate all the properties. Right? That's just a difficult thing to do. And I think if we had better support for doing these kinds of things, it could really help.
Yeah, very interesting topic. So let me think here. We've talked about language, we've talked about DDD, we've talked about database. What are your thoughts on dealing with dual write operations? Like you have a database and two users are causing an update at roughly the same time. Any thoughts about how to deal with that? Yeah, well, I mean, the dual write, so this is something that I feel like has been plaguing me as a software engineer my entire career, is this idea that like for example, with domain-driven design, what you're encouraged to do is you define events. Right, and so you use events to record what happened to the entity and to then use that to reconstitute the state. But you can also use events for integration, right? Publish an event, somebody else subscribe to it. That's a very, very powerful model. Well, okay, great. Let's start doing that. How do we do it? We're using SQL Server. So where are we going to publish the event? Well, let's use like Azure Queues, for example, which would be a pretty bad choice for publishing events. But as soon as you start doing that, each one of your operation updates the SQL Server database or whatever database you might have, and then it publishes a message on a message queue. And this is supposed to notify other systems that something took place. Well, that works great. But sure enough, you're going to run into scenarios when you update the database, but you fail to update the message queue. And so in rare cases, you might be able to have a scenario where they're coupled by a transaction coordinator of some sort, like the Microsoft distributed transaction coordinator. But most of the time, you don't have that luxury, right? And so some of the things that have been done, like for example, at Jet, to address this problem, we just said we're going to use Event Store instead. And it certainly did this part pretty well. Cosmos, actually, Microsoft was working on Cosmos when we started building Jet and Event Store. We didn't have it yet. But Microsoft actually told us that we influenced them to build in the change feed in Cosmos because we were asking for this kind of event sourcing driven approach. And so the change feed is a core part of Cosmos.
that does address this particular situation. You could update a document in Cosmos, and then it will be sure to emit that event in the change feed, right? And you could have the change feed is a lot like Kafka, right? So it's like a log. You can have many subscribers; they each have an offset. And so without, I would say, if you're not using Cosmos and the Cosmos change feed, I feel like, how do people solve this problem based on what I've seen in the wild, right? Like I've seen other systems, other code. I did some time consulting, and I've seen things. And most of the time, people don't actually address this. They just have these errors, and they have to fix them manually. And now I'm wondering, what have you seen that people do to address this sort of problem?
For me, well, I did mention Debezium previously, and here's the thing, right? Event Store is a great product. They've really changed their approach to things from being an event store to being a database, right? They want to be that's what they want to be to the market. But actually, on several occasions, I've had a hard time convincing clients to use it. So, I'm not saying, I can see why someone with your, advanced abilities and, other companies are willing to do that. They probably, even have a relationship with the people who work on Event Store, right? And so forth. But, most companies really, they still want to be able to use. I don't see Oracle being used that much anymore. It's amazing. It's really, Postgres and MySQL or MariaDB gets used as well, but I would say Postgres for the most part. And so when you see that kind of pattern where you need to write events or any kind of sort of sequential operations where you're merging essentially dealing with dual writes. Well, you just want to get the inserts because it's, append only, right? And then from the append only, you get this feed through Debezium, which is reading the transaction log. And then there's a plugin, for example, for Kafka. I don't know how many plugins they have, but let's just say that once you have the Debezium feed, you could actually create a plugin for any kind of, queue or PubSub or whatever it happens to be. So that I'm not saying that is the way to do it. And I know that Event Store has, a lot of good. I think they're probably still using JavaScript, right, for some of the more complex queries and things like that, or is that not happening?
I'm not sure. We never actually ended up using that in production, the JavaScript query part of it. Mm-hmm. We would just use it directly. We'd write append events and we'd read the events. But the key thing with Event Store for us was the fact that we could read and append events to individual streams, but then they had like the fire hose on the back, which with all the events. And that was such a critical piece of our architecture. It was like the backbone of the whole architecture at Jet, where all the other systems were basically downstream from Event Store. And so if we needed to index the data, we put it into Elasticsearch. If we needed to look it up in any sort of way, we cached it in Redis. And sometimes we projected it into SQL for reporting purposes. But yes, I don't know if I'd recommend it. It was a really intense technical challenge to operate that sort of thing. Like we had to build the replicators ourselves, and there's no ecosystem around Event Store to the magnitude that like SQL Server has, right? So even having a UI, documentation, all that sort of stuff was a bit more difficult. But it was very good in that it kind of forced us to do event sourcing everywhere, which is actually really nice. We were saved so many times by the fact that we had a history of all the events, and I think it also led us into this asynchronous architecture where the systems were all pretty well isolated from each other. And as opposed to the typical approach is to build a very kind of synchronous application, that's the easy, and that's the right way to build a simple application. But if you want like a bigger application, you want it's going to be a large team operating it, then making it asynchronous is very helpful.
Yeah. Another thing that I've done, which I wrote about in my red book, and I've talked about, almost endlessly, is simply keeping track of the most recent row that you've written into a relational database. Like if you're using a sequential, like a sequence or an auto increment or something like that, you can track that. And so you can just have a reader that reads asynchronously, the rows from this database. The one problem that you can run into, which is kind of an interesting problem to solve, is that there is a chance that maybe even a greater probability than most people realize is that when you are using sequences and auto increment, that you can actually have a race condition where one thread will get the next auto increment or sequence, and the next write attempt but in another thread will get the other one. And let's just say, for sake of illustration, that the first sequence is 1 and the second sequence is 2, but 2 is able to write the row before 1 writes it. And you can query, because of the transaction, you can actually query from 0 forward, and you can miss 1, right? So what we've implemented on the Zoom platform for this kind of situation, especially because we're using actors and there's all this asynchrony going on, is we actually detect gaps, and we have a sort of a protocol that says, okay, if you see a gap, we're going to do this many retries, and it's all configurable. Let's say 3 retries, we're going to wait a millisecond or 2 or something like that between each one. And if we still see the gap, we're going to log it and say, okay, we have a gap here. It may be a gap because of a failed transaction, right? Mm-hmm. So that can happen too. So it's an okay gap in the sense that, it's not a problem. It's expected because of the failed transaction. But what if it wasn't? So it's kind of an interesting, cool problem to solve.
And this is the other kind of new paradigm you have to keep in mind when building a distributed system. You can't just have an in-memory lock. You can't just you can't enforce mutual exclusion, and so you have to use this kind of approach, right? Just attempt the operation optimistically and then retry. Otherwise, kind of like optimistic concurrency control, right? You can't lock it, but you can at least keep track of the fact that it's been updated. And this actually comes up with building systems. Like I was saying, we have a pretty junior team at Alvis, and one of the engineers was working on this problem where they needed to have like a unique sequence number on an entity, and it couldn't be a GUID because it had to be user legible, but it had to be sequential and contiguous and unique. And so when they first wrote the code, the way they wrote it is like read the latest one from the database, increment it, and put it on Unity and store it back. And of course, that wouldn't cause problems until much, much later. And so then I asked them to solve it, and they solved it using a lock, an in-memory lock. They said, well, there's only going to be one of these running, but then what if there's a second instance of this whole API? Well, then you have to go back to that approach.
Yeah. Actually, using the actor model is another good way to solve problems like that, because you can't serialize never block, but still serialize the request for whatever, right? Mm-hmm. So you're only dealing with one of those messages at a time, and that message has, full access. In fact, Martin Thompson talks about what's called single writer, and single writer is actually to eliminate database contention is one of the fastest ways to insert data into a database. So it seems counterintuitive. It's like, no, well, if I could have 100 different threads writing all at once, that would be much better. But actually, no, it's single writer has some of the highest throughput. Of course, batching is important there, because if you're constantly like one thread just going boom, 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 talking to the database over a network for that matter, it can actually slow things down. So batching those inserts is important.
Yeah, and I mean, there's some nuance to that. Yeah, single writer, but it's a single writer per something, right? It's per I/O resource, per I/O subsystem. And for example, one of the limitations EventStore had on Azure is that it did have a single writer thread, but the whole database was a single writer thread. So that meant it couldn't take advantage of the fact that the file system is what's really the reason for the single writer, right? But if the file system is partitioned, you could actually have multiple writer threads as long as you split the partitions correctly. And so yeah, but within a single partition, you definitely want like a single reader, single writer, and that's EventStore does that pretty well. Like Kafka does that pretty well too. This sequential writing, they really make it go fast.
Yeah, like Udi Dahan told me a few years ago that his friend Ayenda, the RavenDB guy, is actually creating his own. Evidently, I haven't followed up on this, but evidently, in order to get the performance that he wanted, he was actually creating his own file system for RavenDB.
I remember he was. I remember he was actually talking about that a long time ago. But I think he was like reusing some other file system or some underlying data store. But I mean, he can do that kind of stuff. Yeah. But like. But I mean, he's not going to take it all the way to like implementing a new type of data structure called an omega tree that optimizes on disk storage. I mean, that's a little bit excessive there. Yeah. But Microsoft can.
Yeah. Well, it's just a point of interest. I think Udi's comment to me was, I really, like we with End Service Bus, they don't implement infrastructure, right? He's like, no, we do not create our own even messaging systems or anything, messaging mechanisms. They always write on top because he's like, well, no, we really don't want to be in that business, even though Ayenda, is like willing to go down to the whatever, the disk level. But the other thing is, okay, so you have your own file system. How do you get that deployed to Azure? I don't know. Like, does that,
exactly.
I don't think that could happen. But anyway, I don't know. Maybe he's already accomplished that. So, okay, so let's go a little bit into a slightly different subject. I guess we've talked about the N-tier or 3-tier architecture and a way to avoid that through, like, for example, Service Fabric, the actor model. But any other thoughts on how to deal with that, like running the code closer to the data, maybe?
Well, the broader topic of mobility of the code, right? Like we already see the desire for that, right? Like most modern web applications, they have a back end and they have a front end. They have increasingly heavy front ends with JavaScript and all that stuff. Well, JavaScript is code, right? It happens to just run on the client side. With Node.js, you can have it both ways. Why not also take it closer to the database? And so mobility of code is very, very interesting. And one of the things I want to explore as a next generation architecture is actually using this Blazor.net framework from Microsoft, where you can write C# and it'll generate the front end code optimized. It'll obviously be your back end code, and then using that with Service Fabric, where you can have this in-memory oriented data management. And so I think that'll be really, really interesting, because right now, in many ways, the front-end logic replicates some of the logic on the back end, or vice versa, right? Like the easiest way that comes up is validation logic, right? Like, we certainly need to validate on the back end, but then it's nicer to do it on the front end. But then are you duplicating the logic? And duplicating, most of the time, you are going to be duplicating the logic, but you can have some sort of code gen. And so I think that's going to be an interesting area to see if we can actually write a system and then later decide, have that be a configuration that says, okay, compile the system in such a way, hey, deliver some of this code to the front end, run it there a little bit, deliver some of it here to this database, or run it there. I think things like that will be interesting. I also think that where one of the things where the cloud could go is being more and more first class, right? Where you would literally write the whole system as just code. Because now you write code, most of the things that the code does is like data management. The system architecture isn't really evident in the code, right? It's sort of on the outside of the code. It's implied by the fact that you have a connection string to a database, and then you have another service with another connection string to the stream on that database. And that's what implies that these two systems are connected. But it'd be nice to write that out, to say, I have the service here that subscribes to this service here, and have this representation of the system in the code. And then you have that model, and then it compiles to a certain type of infrastructure on a VM, a certain database, and all that sort of stuff. Just like we have on a smaller scale, there's this thing called staged programming. I think it's called staged programming, where like they use some of those things to kind of like optimize link expressions, where you basically do something that generates some code and then runs it more efficiently. For example, if you have like a complicated link expression in C#, right, you have a bunch of where, select, where. Well, you can fuse that into like a very, very quick for loop, right? And so staged programming allows you to do that stuff. It sort of compiles the code into a more efficient form. I'm wondering if we're going to see a lot more of that sort of stuff, like first-class system architecture that then fuses into like a very efficient binary almost, right? It runs like on a Raspberry Pi. Because I feel like there's so much inefficiency in software, right? And any software engineer knows how much inefficiency there is in software across all the layers. And it just seems like so much has to happen for like a web app to come up. I wonder how much electricity we could save, how many trees we could save by.
I've been saying for a long time, and I think people, view this comment or viewpoint as sort of at least avant-garde, if not ridiculous. But that many of the enterprises that I've worked on could run most of their enterprise software on Raspberry Pis. Like if they, truly, I mean, I'm not joking. And there are Raspberry Pi cloud hosting operators out there now. There are, you can create Raspberry Pi clusters and things like that. They're really inexpensive, and they're low power. And I don't know, to me it just makes perfect sense. I've always I've said for a long time that I need to just take like a few months and do that, and prove that it works. And unfortunately, I never have time to do that. But could we work on that together sometime?
Yeah.
That would be fun.
Yeah.
So, okay, let's talk about DevOps and site reliability engineers, right?
Yeah.
SREs. So, what are your thoughts on that?
So, I have a lot of thoughts. I had a really fortunate privilege of working with what I would say is some of the best in the world when it comes to SRE. My boss at Jet was a guy by the name of John Turek, and he came from Google, and he was running their ad serving platform, which is kind of important for them. He was the SRE director on that, and so he really created a very strong operational culture. And like I said earlier, what's really an operation? What's a service, right? Because we used to write programs, but now we're writing services. What happened? Well, a service is a program plus an SLA, which means that sure, it has the business logic, but it also has the operational concerns. How much load can it handle? What happens when there's an error? How do you fix the error? Like, how do you communicate with the customer? And what's the maximum latency it should experience, and all those sorts of things. And that's those are very, very important things. And the skill set required to be a good operator in production is very, very different from writing code. And so shipping code into production, I was just writing a post earlier today about how back in the day, like back in the 90s, I remember the story of how the Microsoft Word team shipped their version of Word and then went on a vacation for 2 weeks. And of course, today, that doesn't really work, because when you ship your code, that's when the real work starts. That's when you discover all these issues with it. And doing that requires a skill set, requires practice.
Yes, we do test in production.
Oh yeah, of course. And again, it's like, of course you're going to do unit testing and all the testing, but no amount of testing, no amount of planning is going to identify what happens when the rubber hits the road, so to say. And so to that end, you just need to have a process for doing that, a protocol, training. And so the first thing you got to think about is monitoring and metrics, right? You have to make sure that you're able to understand the state of the system based on the telemetry that you're getting from it, because you're not going to be able to log into the machine. You're not going to ask the user to send you what they saw through the Chrome debug window. You're not going to run the debugger through the code. Sometimes it's even difficult to run a profiler on a production application. So you have to rely on this telemetry, and you have to kind of embed that into the development process. It can't just be an afterthought. You have to really think about it right away. The other thing is then you have to make sure you have the infrastructure. And that's one of the things where things have gotten a lot better. Like Azure has such a great solution for this. You don't have to think about it. You write your code in C# and then all the metrics just show up. You could slice and dice them in any way that you want. Distributed tracing, everything is already baked in. But that wasn't always the case. And so you have to spend a lot of time making sure the code is instrumented, making sure you had the platform for indexing all these logs, displaying them, considering logs versus metrics and all that sort of stuff. So that becomes a very, very important part of the development process. But then being able to actually monitor the system, generate alerts, and debug the system in production, that's a whole other skill set, right? And it's just something that requires practice. You get an alert, you have to be able to correlate that to see if there's user reports of errors. You have to look at all these different metrics. Sometimes the slowness is reported. Well, what's slow? Why is it slow? What's the bottleneck? Being able to find that. It could be a bunch of different things. It could be the network, the machine, could be your service, could be one of the actually very difficult issues to debug is when the code is written in a blocking way. So it's not using non-blocking IO properly. And obviously that doesn't cause exceptions, but sometimes you run into like thread and socket exhaustion, and it doesn't tell you like where the issue is. You just have to kind of know that this is what happens when you're improperly using async await in C#. And then on top of that, there's all the review processes. For example, a production review process, as we call it, is one where we look over the past week, we look at all the incidents, we see what happened, we make sure that there's a fix on the way. Well, the fix needs to be on the way during the incident, but make sure that there's a long-term solution, making sure that we're following up on it. So all these aspects are very, very different from software development, but they're just as important for providing a good user experience.
Yeah, my viewpoint of DevOps, not so much. I don't really have a lot of. I've read the Google Site Reliability Engineer book and everything, so that's sort of like my level of insight on that. But for DevOps, I think it's something very natural. I mean, I've been doing DevOps since way before there was a name for it like that, and I don't know. I guess one thing that a lot of people complain about, and I think rightfully so, like AWS, right? How much investment do you need to make in knowledge in order to really succeed with AWS at a DevOps level? And actually, a lot of developers say they just prefer not to deal with it. And we actually use AWS for our product, Domo, a modeling tool, an event storming tool. But we use it through a platform that, abstracts AWS for us. And we use Lambda, right? We use AWS Lambda, but it's not directly Lambda. We have the advantage of having a layer above. Well, I deployed 4 times yesterday to our abstract or platform abstraction. It's still DevOps to me, right? I don't know what do you think? Is that like, well, no, because you're not in pain and taking, Alka-Seltzer every hour. It's not DevOps.
Well, I think that so in my view, I think there's no clear definition of these terms, right? Like SRE is one thing, DevOps is kind of, but I'll tell you that at Jet, for instance, we had a DevOps role. Like we had a team, they called themselves DevOps. And some of what they did was this monitoring, but it was also the product engineers doing the monitoring. One of the things the DevOps also did is control our cloud resources, right? It's like the cloud is more and more complex, and it takes a skill, it takes knowledge. Like, what does it mean to spin up a VM? What does it mean to increase the RU consumption on Cosmos? How do you set up the networking? How do you manage all the different environments? So that's what our DevOps team did a lot of. But with that said, they didn't necessarily do like the core application development, right? So it was kind of interesting where DevOps, I thought, was supposed to be where the developer does operations, but it actually became like more of an SRE role where they weren't really working on the application. They were focused on like the infrastructure. With that, they were in the first line of attack of everything, right? Because like they would get all the alerts right away, and they would try to see if they could handle the issue without calling the engineers. But most of the time, the engineer had to look if it's like an application issue.
Yeah, and I think if you talk to some really, I guess what you'd say hardcore DevOps people, that is absolutely not DevOps, right? Where you have a operations person who is not a developer. It really, I think it was meant to mean developers doing operations, as part of their role, instead of having a completely separate role for that. I mean, my experience in, previous years where everything was in a data center, you had these operations people who took your code and deployed it, and it was usually a pain. It was like, okay, when is this going to get done? Or it was on a weekend, right? You got to work on the weekend to have a release and all these things. So, I mean, from that standpoint, it really is good when you can control that, and you can even roll back a release if there is. I rolled something back last night, right? It was like, oops, that production test, failed. So let me roll that back. But, so, I love the flexibility, but I think if I had to, we're a boutique, services and product company. Like if we were to try to go all in on AWS or whichever cloud platform, we would probably mostly not be nearly as productive as we are right now, right? And it would just take too much, gray matter to to invest in that level of platform that I think it's just not worth it for most, small startups or something like that. Plus the fact that you can burn through capital, by mistake really quickly. I don't know if you've ever seen or heard anything about those stories.
Oh, I mean, yeah, we've had those stories where, Azure will gladly take your money, and I remember we did like a load test with Cosmos once over a weekend that cost us $200,000. But I think we tried to like recover that somehow, because that was like, it wasn't meant to do that kind of thing. But the point being that if you allocate your RUs, your resources in Cosmos to such a scale, they'll take it. They'll handle the load and take the money.
The previous record that I heard was $100,000 over a weekend. So you win. Oh, okay. You're like, that's pretty. Yeah, I guess hopefully they would say, oh yeah, we can see that was a mistake. So let's not put these guys out of business or whatever. Yeah. Create a big hardship, make some investors really angry, and whatever. So yeah. Well, so just tell us a little bit, and kind of wrapping up. I wanted to talk a little about the startup that you're working in. It's actually in an industry that is kind of low tech, right? Or maybe becoming high tech, but trucking, I think it is, right? And so how are you optimizing the trucking industry?
Yeah. So Alvis is what we call it as a carrier operating system, carrier trucking company, and you're actually right. It's a pretty low tech industry. They have some high tech things, but the reality is quite grim. So if you spend some time at one of these carriers, seeing how does the country move freight, how do things move around the country, and of course they go on a truck, but what happens in between? And it's a lot of stuff. It's a lot of things that happen. And if you visualize what it takes to move an individual truckload, how many people have to collaborate, how many people have to interact, where usually the business, the players in this industry, the freight industry, are the carriers, the trucking companies, of course. And there's a lot of them. There's like 800,000 carriers in the US. Most of them are small. 90% of carriers have fewer than 20 trucks, I believe. Fewer than 6 trucks, actually. Yeah, fewer than 6 trucks. Right. So most of them are small. There's a few mega carriers, which we have, like Walmart and Amazon are the mega carriers. They're not really part of our market because they have their own stuff. But there's a lot of these little carriers. They're a big player in the market, of course. Then there's the actual shippers, right? Like Tyson Foods, King Soopers. Those are the guys that would like to get stuff shipped. And then there are the brokers in the middle, the freight brokers. So the freight brokers are kind of like a middleman, where they maintain a lot of these carrier relationships. They have contacts with a lot of carriers, and they provide a service to these shippers wherein they'll take their loads and find a carrier to move it. And on the one hand, it seems kind of like a middleman type of role, but it's a very important role because of how fragmented this market is. And for a shipper, it's a lot more convenient to work with a broker that will be sure to cover their load, as opposed to working with like a lot of carriers who have small fleets, right? So that's kind of the structure of this market, and there's really no technology for these carriers to operate their business. Now, there's a lot of technology out there that's called a TMS, for example, Transportation Management System. In reality, most of those systems are focused on the shipper. So they allow the shipper to think about, like, okay, you want to build a load, you have your orders, you put them into a load, here's how you pack this load, and then here's the load number. But now you go find a carrier to move it. And even if they have something about helping them find a carrier, usually the exchange between the shipper and the carrier is a PDF file that says, here's the load, and that's the communication between them. And so again, if you look at how a load is moved based on the perspective of a carrier, and this is how it goes. They have these people called dispatchers, which are all day they're looking for loads to put onto the trucks that they manage. They're making sure their existing loads are being covered, right? So they're always looking for loads, making sure that to talk to the driver. If they find a load on a load board, so there is a little bit of technology. There's these things called load boards, where a broker can go and they could look for loads, and a carrier can go and look for loads there. But the extent of the load board is that you have some filters to narrow down the geographic area, but then there's a phone number to call and say, okay, hey, is this load still there? And then there's a lot of phone calls. Usually after the phone call, an email gets sent into Gmail. So then the dispatcher goes into Gmail, gets the information from Gmail about the load. They usually start texting the driver because they already know the driver that's going to be working with them. They text the driver. They see the driver's schedule on an Excel spreadsheet that they painstakingly maintain every day. Then they text the driver to get moving. Then at the end of the day, they usually have to make sure to record all the things that they did so that the rest of the team can recover the process and take it further. Usually there's like an overnight team that handles like calls from drivers at the night. But again, there's no real software here besides Excel, besides your iPhone and Gmail and a few of these load boards. There is technology for tracking, for example, and that was actually back in, I think, 2015, the government mandated the use of these electronic log devices, ELDs, for drivers, where it basically limits the amount of time they could drive in a day. To avoid these scenarios where drivers drive for too long. So they do have these ELD devices that the drivers have to use. And so there's a few tech companies that provide these devices. In addition to tracking the hours, they also track the location. And there's a few other visibility type of services tracking the locations of things. But other than that, there's no real operational system for these carriers And so usually what the larger carriers do, larger meaning like 100, 200 trucks, they actually maintain the schedule for their drivers in Excel. They have an Excel spreadsheet that's shared, and everyone painstakingly has to maintain it, update it every day. And that's kind of like the center of their operation. And so what we did is we came in, we took that spreadsheet and made it into a reliable internet service, to put it the quick way. So Alvis is a pretty simple thing, right? It's not like inventing a new type of technology. It's just doing a basic thing for people to help automate their workflows. Is that right now you go into Gmail, you go to all these different things. We bring it all into one platform. They have all the load details in there. They could text the driver from the load. They could invite other carriers to look at this load. They could see where the drivers are. All the tracking data comes in. And so we help the carrier with their operations, which is, again, looking for loads, handling existing loads, and then looking after the fleet, like making sure the trucks are repaired, all the licensing is there, all the trailers are tracked properly. So that's what Alvis does. One of the surprising things to me coming into this industry over the past couple of years was actually how little has been done before. I thought that this would be a solved problem, but it totally isn't. People are spending their time working on like crypto or social media and all that stuff. But if you want to solve a real problem that's going to really help the world, the planet, like the amount of wasted miles, empty miles, missed opportunities we can create if people adopt this technology is just going to be amazing.
Yeah.
And so that's what I've been working on. It's an overlooked industry. Silicon Valley has overlooked it. I don't know how that happened. I don't know. The big players like Oracle has like supply chain stuff, but it's like everything they have is like legacy. It's like old school, like floppy disk type of stuff. So we just found this opportunity. And how I got into this, right, was that I ran into somebody that was already doing this. I ran into somebody that was actually an operator of a trucking company and a freight brokerage, but one that was tech enabled. Like they actually started building their own stuff, their own operational tools, because they saw that nothing else worked. Nothing else worked. So my business partner, Nick, who's the founder of Alvis, he tried a bunch of different things. And so he started building his own software. We partnered to then take whatever he built for himself, and we spun it off as Alvis as its own technology company. And so we take his operational experience, the hands-on experience, and actually building this thing in the first place. And I'm kind of taking it and turning it into like a proper, reliable service with an SLA and everything.
Cool. It might surprise you to know that I actually have a very good friend who was previously running a trucking company. And back in the late 90s, actually, we were talking and he was like, a problem that needs to be solved is backhauling. Which you're probably aware. And this is pretty much what you're talking. I don't know if it's exactly on the mark.
It's exactly what I'm saying. Yeah, backhauling. So empty miles. So backhauling involves empty miles, right? Where you have to travel additional distance because you didn't sequence your loads properly. You have to return on empty. Yeah, that's a huge problem.
Yeah. Do they call it deadheading or something like that?
Deadhead, so deadhead is basically the meaning that's the distance from the point of where the truck is to the pickup location. Mm-hmm. So you want to minimize the deadhead, finding the one that's closest, right? But overall, the other term for this general phenomenon is empty miles, where you just the truck is empty, or the truck is with an empty trailer, or anything like that, or the truck is like partially loaded, which actually happens quite a bit. And again, even with Alvis, right, we're just scratching the surface. There's still so much manual stuff. Like we can't build things quickly enough. And so we're in the stage now where we have customers, we have paying customers, but not very many. We just really started to sell back in April. We're trying to accelerate our sales, grow our product while keeping a reliable system. So it's kind of like a critical time for us. This next year is going to be kind of like a make it or break it year. Are we going to onboard enough customers to make it to the next level, or is this not a thing? But we're getting a very good feedback because this market has been so overlooked. The software that we have is actually pretty good. People get blown away when they see it. Some of these people are coming from like desktop software. like there's this program called Pro Transport. It's a desktop like Windows type of thing, and those users are they're one of the things they're really amazed about is you could have multiple windows. They're like, wow, like you could have two loads open at the same time. That's not something they gotten used to. And that the software, it's like to give you a sense of what it's like. Nick, my business partner, calls them glorified spreadsheets, where like there's this view that looks like a spreadsheet that describes a list of loads, and then there's a cell where you would specify the driver that would handle it, right? And they do have a track, they do have a list of all your assets, so you can click on that cell, and then there's a drop down of all the trucks that you have. But that drop down is just alphabetically sorted by the truck number. It has nothing to do with what the load is, where it is, where the driver is. The system doesn't think about that stuff. So you have this like drop down of like 100 trucks, and you got to find the right number, and the system won't tell you anything of whether that's a good decision, whether that truck is doing anything or not. So that's kind of the world that they're coming from. And all we're doing is kind of like doing the obvious thing in this case, and shipping it as a feature.
Yeah, cool. I would think, actually, I think you alluded to this, but I would think that the marketing and sales is the harder part, like getting the message out, right? Like how, like these people are not watching, like, I mean, I would assume not on like tech forums and things like that, or,
So it varies. So the larger carriers, what we found, they are very sophisticated. They can be, right? Some of the really large ones, I know this carrier out of Chicago, they have like over 400 trucks. That's a major operation. Like they have their own development team, and they actually do try to do stuff. Some of the other ones, they're sophisticated in a sense that they do try to find software. They are trying things, and in order to be a good operator at that scale of 100 trucks, like you have to be doing something right. It's like not everybody can take a company to that level, and one of the ways is thinking about efficiency. It's just that I think part of the issue is that what needs to be built is complicated enough to where you can't just get a trucking company to do it, even if they have like, good income. A trucking company is not going to be able to build like a super solid engineering team to build this kind of thing. But it's not that complicated where you need something overly specialized, or you just use the regular development tools that you have at your disposal. The cloud is very mature now. .NET, C# are just very, very nice and cozy these days. And so we just have to execute. But yeah, I mean, the marketing piece is difficult. This industry is quite interactive, actually. Like I just got back from a conference. There was another one the week before. I'm going to another one next week. So the freight industry overall is quite social. And so people are on the lookout for things. It just has to be a fit. There's a lot of challenges here, right? This is a very big piece of software. It's pretty complicated to use. It's a big commitment to onboard to it. The software has to be super reliable, super fast, no data loss. And so it's like a big, serious decision for a carrier to transfer it into it. And so we have to really tell a good story, provide a good value proposition. And I will say, though, that reaching these smaller carriers is going to be indeed a challenge. So these owner operators, a lot of them are like just some guy owns a truck. He drives it, answers the phone, it does everything off the phone. There's a lot of those, and those are going to be harder to reach because they're not necessarily attending conferences. They're always on their car, not really on browsing the internet as much. We have to find a way to reach them more effectively.
Yeah, absolutely. Well, this has been a really intriguing conversation because we went, pretty deep into technical stuff and also business, and we learned a little bit about Alvy's ubiquitous language, or at least part of it. Mm-hmm. So very cool, and it's also probably the longest podcast I've ever had. So No. I mean, this is great. I mean, to me, it's like there's a lot to learn here. So if someone needs, 2 commutes to listen to it, that should be fine.
Yeah. Well, in Alvis, I feel like there's a lot more to talk about in terms of domain-driven design at Alvis, because it's like a must for us to really invest into the domain model, where we really need to, because a lot of times it's tempting to just start writing code, right? But in our case, like we really need to like whiteboard it out and I don't know if I have anything interesting here, but
Yeah.
like we really need to model the thing and really write down the language before we start doing a lot of coding.
Yeah. Well, so should people, if people are interested in writing some C# and working on Azure, should they contact you for work?
Yeah.
Okay, so we'll have that on the podcast page for you. So yeah, it's been really nice to talk again, and best wishes on your venture.
Yeah. Well, thank you. Let's keep in touch.
Right on.
Thanks for having me on.
Okay.